The following phrases and words are properties or descriptions of one or more of the transformations we have studied so far. Translation, reflection, and rotation. Determine which type of transformations the statements describe and write your answers on the line. An example of each type of transformation is provided. So once again, I'm just going to point this out. The preimage, if it's pointing to the left, it can sometimes point to the right after a transformation, but it's still the same size shape. We could flip it and just kind of trace it right over this one. Same with the translation. We just moved this thing up and to the left. Or a rotation is just we moved it or rotated it right here. Yeah, let me... All right, to flip is a reflection. And to slide, this one's still a translation though. Then we got some turnage, which sounds to me like it would be a rotation. Then the image has the same orientation as the preimage. That usually only happens with translations. I'll abbreviate that for time purposes. Specified by a figure, a center of rotation, and an angle of rotation. That sounds to me like a rotation. Specified by a figure and a line of reflection. Well, that sounds like a reflection. Specified by a figure, a distance, and a direction. That sounds like a translation to me. Segments connecting corresponding vertices of image and preimage are the same lengths. Let's think about it. These. Certainly a translation. That's not necessarily true with reflections, but rotations, is it possible?
But not always.
No. Yeah, very few instances. Yep. Corresponding image and preimage vertices lie on the same cycle. Rotation. Segments connecting corresponding vertices of image and preimage are parallel to each other. That sounds like a reflection or a translation. Line of reflection is the perpendicular bisector of all segments connecting corresponding vertices of the image and pre-image. Line of reflection is used only for reflections. It's possible to use perpendicular bisectors in rotations, but it's to find the center of rotation. Concentric cycles. That sounds a lot like a rotation. If it ever talks about cycles, which we saw in the lesson last time, and we're looking at rots. Orientation of the figure does not change. That is true for translation. The sloppage of corresponding segments may change. That is usually true for rotation. Corresponding segments in the image and preimage are the same length.
All of them.
That's correct. So if it is a reflection, rotation, translation, that is true for all of them. Corresponding ankles in the image and pre-image have the same measure. Yeah, that's true for all three. Very good. Parallel lines in the pre-image remain parallel lines in the image. All right, yes, it is true for all three. Those last three specifically are describing congruent shapes. Observe the two figures below. Okay. Describe the ways in which the figures are the same and the ways in which they are different. All right, in what ways are these the same?
Just for you.
Well, it's the same shape. It's just been oriented differently. All right, so this one could be a reflection if it were reflected across the line x or y equals x. So some 180-degree rotations usually, well, at least for the origin, are the same as a reflection over the line y equals x. All right, the two figures above are said to be congruent. In 7th grade, not that anyone pays attention, but you learned that two figures are congruent if they have the same shape and the same size. In 8th grade, not that anyone pays attention there either, we defined congruence in terms of transformations. A two-dimensional figure is congruent if to another if the second can be obtained from the first by a rigid motion, which is rotation, reflection, or translation. We've gone over all three. Or a sequence of rigid motion. If you can move one of the figures using one of these transformations or a series of these transformations so that it fits exactly on the other one, the two figures are congruent. So B, in this case, there are several different transformations that will carry one figure onto the other. Describe one transformation that will carry A, B, C, D onto A prime, B prime, C prime, C, D prime. So there's a couple. There's a couple for us. The translation, reflection, and rotation are described as rigid motions. Describe in your own words what that means. So this is what I got. I mean, you may have something close to it or different a little bit. But taking a shape and moving it without changing the size of the shape. So we can change the orientation as well. It's just about changing the size. Once we change the size, then it's not the same. It's not congruent any longer. It says these two figures are congruent. Describe the transformation that will carry LMN onto EDF. Now it's important to remember on these. The order of the letters is quite important actually, because E corresponds with L, M corresponds with D, and N corresponds with F. So we can kind of see that this is some kind of reflection. M moved to D, N to F, and L to E. But this one, I mean, if you say it's pointing up and to the left, this one's pointing up and to the right now. So the orientation did change.
It's a reflection.
Which means it has to be either a reflection or a rotation.
It's a reflection.
So one of these could be a reflection. Where would that be? 1, 2, 3, 4, 5, 6, 7, 8. So this would be our line of reflection. Now at the same time, it is possible. Let me see if you could rotate this thing. Nope. I do not see that a rotation would work. 360, we'll just put it where it is somewhere. But it needs to go to DEF, so that's no good. Corresponding figures have corresponding parts. They're matching sides and ankles. For example, in the figure puff, LM corresponds to ED, and angle D corresponds to angle M. List the other corresponding parts below. All we need on this is to see. Alright, knowing that triangle LMN was transformed to EDF, shows how these should correspond. So LN should correspond to EF. We're just looking at the same positions in these two. LN is the first letter, N is the third, E is the first, F is the third, so we put them in the same order. MN, that's the second and the third letter, so it should be corresponding to DF.
I used to like it riddles.
Yeah, right, like hieroglyphics. Or ankle E,
L.
then must correspond to ankle L. Very good. Ankle F would correspond to ankle N. We can write a congruent statement for the two triangles. You can denote the two figures are congruent by using the symbol. That's the congruent symbol.
Wait, what's the congruent symbol?
This one right here.
I don't see.
Congruence is this symbol. It's an equal sign with the Enye symbol above it.
Yen
So it's equal A.
Pi, isn't it?
And listing their vertices in corresponding order. Yeah, so they correspond with each other. L corresponds with E. M corresponds, oh, not that one.
Did you say Enya?
M corresponds with D. N corresponds with F. In the example above, we could write this symbolically as triangle LMN is congruent to triangle EDF. The order of vertices is written, tells us which segments and angles are corresponding in the figures. That's how we can figure the stuff out above. Corresponding parts of congruent figures are congruent. Corresponding segments have the same length and corresponding angles have the same measure. We can show this symbolically in the following way with all 6 of these. We can also annote the diagram to show which parts are congruent. Do this on the diagram above. Let's do it. Alright, so LN, we give a mark like these. So we give EF the same mark. LM, we give 2 marks now because it's different. And it corresponds to ED.
Wait, where is it?
So it gets the same number of markings. MN will get a different number of markings. And it corresponds to DF, which is the same length. So it gets the same number of markings. Now that is just for those side lengths. Next up are the ankles. Ankle M, which we will give 1 mark.
That's what I break every day.
So ankle T also gets 1 mark like these.
I know.
N, which corresponds to F, will give 2 marks. And F then will also get 2 marks because they correspond. L can get 3 marks. So E can also get 3 marks like these. Now we can see which parts correspond with each other. If you can use some colors like I did, then it looks really pretty.
Yeah.
Two objects below are congruent. That's great. Describe the transformation that will carry XYZ onto PRQ. This one appears to be some kind of reflection. But I would say that it's a reflection and then some kind of translation. Alright, list the congruent corresponding parts. So on these, to look at it, all we got to do is really look at this statement up here. Alright, we can see up in here that, let's start with the ankles. Ankle Z and Q are the same. So ankle Z is congruent to ankle Q.
Isn't it P?
Then we can look at X right here and P, which are corresponding. So ankle X is congruent to ankle P. There's our third one. But those are just ankles. Now we got all the side lengths up in here. So there's our first one. Next up is, we got this long one right here. And that's XY, which is congruent to PR. And then finally our third side right here. We got XZ, which is congruent to PQ, sorry. There we go. Now write a congruent statement for the triangles. So we get caught up with all 6 of these congruent statements for the parts. And we kind of forget how to write a congruent statement for the triangles. So it makes it extremely difficult. So I'm going to start first by saying I've got triangle X, Y, Z. And it is congruent, so I need to show that it is congruent to triangle. And the order of these is a huge deal. P, R, Q. Because corresponding parts should be in the same position for each letter. Alright, we don't really need to annotate the diagram because we use the colors to show which parts are corresponding and congruent. Using triangle ABC in the diagram below as the pre-image, apply the following rules to triangle ABC and determine whether the resulting image is congruent to triangle ABC. Always start with triangle ABC as your pre-image. Okay, so we're just going to start over after each one. So A, we got X, and then we got Y plus a 7. So it'd be like taking the shape and moving it up 7 spots. So that's where C prime would be. That's where C prime would be right here. And then A prime would be way up yonder. Because X stays the same, but we're moving it up 7 for the X. 1 each one. So B would be even higher than that. So is the resulting image congruent? Yes, it is. Why? Because it's the same size and shape. All right, on this one, B, we got x y with the coordinate rule, negative x y. So first of all, does anyone know what type of transformation is these? Well, when you got the y's are the same, but the x's are opposites, this is a reflection. And let's see what happens when we make the x's the opposites. This becomes C prime. B would be over here. Yes, B prime. And then A prime would be over here. So that is clearly a reflection. So the answer is yes, because the shape is the same size, if I had drawn it better, and the same shape. Part C, x, y, now becomes x and 2y. So, alright, so x and 2y. So the x is going to remain the same distance away, but the y is going to double, so the c will become radical. That's C prime. The b is still 3 away, but we're going to double its y value to make it up here. A keeps the x value, but the y value doubles to give us A prime. So we have this shape. That looks okay. This shape right here. Well, this is the same shape, but now it is a different size. So the answer are no. So now the rule is to take x, y, and then double x and double y. So on these, we got x is doubled, so now it's over here, and then the y is doubled, which puts us right here, C prime. B, we're going to double the b, the x's, and then we're going to double the y's, which puts us up here, B prime. So A, this is where the x is. So the new x will be double that, and the double the y will be right here. A prime. All right. Now here's the thing: is this the same shape, but it is not the same size. But it is the exact same shape. It's just made bigger.
So yes.
So the answer is no, because they're not congruent because the sizes do have to be the same. But, and we'll get into this in a different lesson, they are similar. So now we must write our own coordinate rule that is different than the ones above that would result in an image that is congruent to triangle ABC. How do we know that it would be congruent? As long as it is only a reflection, translation, or rotation, then automatic it becomes a congruent shape. So one of them was to rotate it. We didn't see a rotation. So I'm going to do these. So I'm going to rotate it 90 degrees, about the point 0, and that would give us something like negative a y, and then x. Alright, this one looks like it would be counterclockwise as well. Alright, that rule would do it. Another rule that would work would be any translation, such as x plus 5, and then maybe y minus 4. That's also a translation. That would make it a congruent shape as well. Write your own coordinate rule that is different than the ones above that would result in an image that is not congruent. Triangle ABC. How do you know that the resulting image is not congruent to triangle ABC? It just has to be something that's not a translation, rotation, or reflection. So we got to make them bigger, just like we did on C and D. So we can keep them the same. We can switch them like these if we want. But we got to expand or reduce them, so we can expand the y. And then we can cut the x into the third. That would give us a very different size shape. And also, well, we'll get into this, but that would be considered a dilation. Any dilation would work, making it bigger or smaller as long as you don't use a factor of 1.